Welcome back again. Our next speaker is going to be Justin. Welcome. So,
hello.
So Justin and me actually are we used to be colleagues in a way because we were both working as competitors back then in the visual testing space. Yep. So it's for me it's extra interesting to see how things have evolved. For in about 3 years, I've been away from that industry. So give it a go.
So cool. Thank you. Well, thank you. It's nice to be here. As you mentioned, my name is Justin Ison. I am a senior software engineer at Apple Tools, working on the customer success team. And those of you that are not aware of what Apple Tools does is we specialize in visual automation, essentially taking snapshots of your application where you create a baseline, and then any time in the future you could do a visual comparison. So today I'm going to talk to you about the age of VR is upon us and using visual testing to help test your application in a deterministic way. So I'm going to talk about the different techniques that you could possibly use to validate your visual content or your VR content. And virtual reality is an extremely tricky thing to do in a deterministic way. And as I've found as I was doing this research to, essentially partially for my company, but what I did as this research, I actually turned it into this talk. I'm pretty sure my hair wasn't gray before I started getting into this. So virtual reality, as you probably know, is a big wide range of many different technologies, different platforms. And so I'm just going to narrow it down to certain types of examples. So desktop web, mobile VR with Android, and VR video. So let's get started. So as I mentioned before, there's several different types of VR. You got the Google Daydream, the Oculus Rift. You have Sony PlayStation, HTC Vive, and this is not them all. There's a ton more. But it's not the same as augmented reality. Augmented reality is a combination of virtual reality and reality. But in this case, we're just going to talk about just virtual reality. So why virtual reality? Why are people moving to virtual reality? Well, it's easy. Companies can actually put their products on, into a virtual reality app, and from your home, you could actually look at these products, see them in all 360-degree views, and you could actually make your decision without having to actually travel and go to a store. It makes total sense for entertainment. Concerts, sporting events, all this is going into virtual reality very soon, especially with the Oculus Rift. They're moving to do that. But you could also look at real estate. Find your new home or tour it without ever having to go visit it. Or go on a vacation. But testing today in virtual reality is tech's wild, wild west. It reminds me of basically the time when smartphones first came out. During that time, there was no frameworks to test these. But shortly after, some came, but just as quickly as they came, they left, just because they just weren't good enough. So my first example, I'm going to go over and show you how to automate desktop browser virtual reality using both Selenium and Apple Tools. So you can see here, this is an example code script in Ruby, best programming language out there. But no, really, it's basically what I use to prototype everything. So I think I can laser point. Yeah, so first here we got this array, and these arrays of different values. And essentially, I'm just going to loop through that array. And each time I'm rotating, I'm going to do this drag and drop by. It's the same across all Selenium bindings. But I'm essentially going to be clicking on the browser and then moving to a different location and looping through that location each time. And each time I do that, I take a snapshot. So in this first example, I'm just doing a 360 rotation around the VR application. The next one, I'm just going to go up and then go down. So here's an example of it running. And at each pause it's going, it's actually taking a snapshot. So now I have my 360-degree view. Now I'm going to go rotate up. And then finally, after I get this, it'll rotate down. But what you get with a visual snapshot is it's essentially an assertion of everything. It's asserting every attribute, all the different colors, all the different objects of your particular app or your view. So now it's complete. So now I'm in AppleTools, and all my images are here in AppleTools, where now I could actually review them. And in this particular case, they all passed, but if there was any type of visual difference, they would come back as a failure. And actually, when I was preparing the slides, I came across a failure. So this shows you an example of a failure happening in what was picked up. For whatever reason, these buttons or these icons weren't showing whenever the test ran, so it highlighted it as a failure. So this could be anything. The Earth could have been missing, or the astronaut turned a different color. These are the things you would catch with visual testing as part of your functional testing. So let's get into native Android virtual reality. So in this case, I'm going to use Appium, which is very similar to Selenium, but for mobile applications, in combination with OpenCV. And so OpenCV is an open source computer vision library, and it is now, like as of maybe 6 months, partially included into the Appium bindings. So as long as you have the OpenCV source code installed on your machine, you could then hook in and do visual, find images within your mobile applications. So validations in non-VR mode. The difficult thing is a lot of times when you get into the application itself, it's not going to be in the exact same place that you need it to be to start your test. And so this becomes a pain point, especially if you're going to do a visual validation, because it might be shifted over right or left a few pixels. So it makes it really difficult to do. So the other problem I ran into is swipe and gesture events to get it to go to a certain place can be also just as flaky and hard to do. So what options do we have? So we could use OpenCV. So the great thing with OpenCV is I could actually identify something on the area that I want to locate, and I could use that as sort of a page object or an image page object in this matter. So just like a selector, like an XPath or CSS selector or so forth, I could just use an image instead. And I could get that image and I could get its location. And as you see, the one downfall with using OpenCV is it's slow. It takes a lot of processing power to find what you're looking for inside of an image. But I imagine the beefier machine might reduce the slowness. So here's another example, some code example, where first there at the top I could get the screen center. So Appium returns me essentially the size of the window, and then I just divide it in half, and I get the XY coordinates of the dead center of the screen. Then going down to the orient screen from image, you can see here that I've highlighted, you can find by image. So I could pass in that image that I showed magnified before, and I could basically get its location returned to me in a hash with an XY coordinate value. But it wasn't as easy as that. So I originally thought, I'd just go from the center of the screen to the object, and then that would put it in the center of the screen. But it didn't work that easy. It basically would throw the object, would go left and right of wherever I was trying to go. I could never get it to work correctly. So I found if I half the value every time, so instead of going, from the center all the way to the object, I would just go halfway. And then I put it into a loop, and essentially a simple Ruby loop is this 3 times, basically runs that block of code 3 times. By doing that, it actually got the object basically within the center. And so by doing that, I could orient the screen to exactly where I needed to be to do a deterministic image comparison. And then, so the last method here is just validate view. I could basically take a baseline that I had and then to a checkpoint. And so here we'll just watch it run real quick. This is just going to orient the view. You can see if we get right there, is that marker is where it's going to try to orient get it into the center of the screen. And this is real time here, so you can see how slow it is as getting the image each time, or finding it. And so you also see the markers. That's actually a nice tool or helpful tool in the Android developer menu, where you could actually show tap events. And it's perfect to help debug these type of things. And it should be just about done. Yeah, so you can see there, it's almost precisely where it needs to be. And so here's an example of it just running. I sped it up. So it's wherever I want my breakpoints or my checkpoints, I just set an image, essentially again like a page object of an image on each location that I want to take a snap point, and it orients the screen, and so I can run it over and over again to be deterministic. And you can see here it's returning scores based on match scores. 0.9999 basically is a perfect pixel-to-pixel match. Even with this approach, you're never going to get a perfect .999. I think anything over 90 is probably good, and I'll show you an example of why. Yeah, so here's an example of why. So you can see just even the slight shifting. Basically, this still was going to return over 90 because it's very close to what it should be, but it's not going to be perfect 999. So Android VR mode. Obviously, this is the VR mode when you have it up to your face. And there's some challenges with this. Obviously, when you have the device in your eyes, you can't swipe it. You can't do anything. And nor does the SDK let you do it. So basically, any commands that you send to using appium send to the device, it just ignores any swipes or taps. And then again, this now, because everything that you've seen up to this point, I can't do. I can't do any type of drag or drop, clicking, tapping. So it adds another layer of difficulty. So also, a lot of virtual reality apps have animations. All I would say for that, if you need to do a visual comparison, is you need to hopefully have the developer give you test hooks, or some type of development build where you could actually pause animations, give you some type of option so you can actually test your application in an automated way. But if you can't do that, if that's just impossible, then your other option is to basically, just like I showed you before where you could find by image, at your breakpoints or wherever you want to do your assertions, you find that image in your application and assert that it's there, displayed, and maybe possibly its location is correct, or any type of attribute that you want. So that's an alternative. So what other options do we have? So we could use Android sensor events. So every smartphone nowadays has sensors. So you have a gyroscope, accelerometer, just to name a few. There's a lot more. And basically rotating on its axis. So thankfully, you don't have to be this guy because we'll do it all on a machine. So luckily, we have extended the control sensor events on the Android emulator now. We don't, which is great because this is exactly what we need to control our virtual reality application. So as you can see, you could twist it around, do whatever you need to do with it, and it's changing its values every time you do it. So how are we going to do this automated, though? Because I can't automate that GUI. I need to basically hook into some type of API, which is great what we have with Android. We have the ADB to send different commands to it. So all we have to do is telnet into the console. And once we're in the console, as you can see, there's several different types of options, but one of them is the sensor events. So here's some more code, basically to manipulate or change the sensors of the device. First, I telnet in then I could send any type of command I want to the console. I could get all the device sensor statuses, whether they're enabled or disabled, get their values. I could set their values, so I could change what I needed them to be, and I could rotate the device, which is one of the most important things, because by default, device is usually like this, but I could actually physically rotate it to be in VR mode that it needs to be, or any type of rotation I want. Those of you might be familiar with Appium. There's capabilities to set the landscape or portrait. Unfortunately, that just rotates the view inside the device, doesn't actually physically rotate the device. So here's an example of just me manipulating, connecting to the sensors and then sending different commands to it programmatically. You can see here some of the sensors will change. I think there I did the rotation. Next, I'll just start messing with the gyroscope. I'm just telling it to turn left. And essentially, I learned the hard way, but this could be very, you could get into a lot of trouble with this. You can actually almost get the device in a chaotic state. Oops. So you can see here I went left and right and up and down. And at the very end here, I'm going to show you, you could get all the sensor values. Yep, so I have all my sensor values there. I have my gyroscope, accelerometer, magnetic field, orientation, and so forth. So now I could take these and essentially make sensor objects. So like we were doing page objects before, I can now have sensor objects replacing those. So here are essentially my same tests. The same tests I did with the swiping, I'm now just replacing that using the different sensor values. Again, the validated view and the score are the same as before, but now I can use these to replace that. And actually, even in non-VR mode, this would work too. So this is a solution for actually both. So here's it running, doing the same thing as the other one did. I sped it up because it is quite slower. And it's finished. So again, it's returning me a score, and I know my orientation and everything is correct. So now I have a baseline checkpoint. So whenever my application potentially changes in the future, it's a way of testing it without having to manually put on a goggles and test it. So a lot of applications, VR applications, have menus. Again, you can't swipe, you can't touch these things. It's all tilting your head and finding the menu and interacting in it with that way. So again, we could do very much the same thing, create page objects, or sensor objects in this case, for the particular menus that are in your VR applications. So I could create scripts with this to tell it to go to these locations, wherever they may be. And then this other method down here is just another example of things you could do, where you could create just a turn left, right, up, and down, but it's a timing-based approach. So instead of giving a specific all the different other sensors, you can basically just tell it to turn left for 2 seconds, turn right back for 2 seconds, should put it back in the same spot, and up and down, and so forth. So here's the example, just showing you how I'd get those values. So again, going back to the emulator extended controls, I would manually set it to the place I need. Then I would, in my REPL, or IRB for Ruby, I would get all my values for my sensors, and then I would just record those. Basically, then I would create those as my sensor objects. And this is just show I went back and reset it, and now I actually, from my saved values, I set it back to where it was, just proving that it was working. And I think here is just going to show you the other method here where it's going to turn. Yeah, so it's just, again, it's just a timing base. You might want to do a circle or so forth, whatever you want, but it's just showing you the options you have capable of doing. So our next topic, VR video. A ton of applications virtual applications are basically based off virtual reality videos. A lot of them are just wrapper apps around a video that essentially just runs. This is 360-degree video. So, as you can see here, I'm just rotating back and forth. It's just showing you all the different things you can see as part of it as a 360 view. The most popular format for these type of videos are MP4. So why don't we just go directly and just test that video? Skip the whole integration test. We could just test the VR video itself. But how? Well, there's an awesome tool called FMmpeg. It's open source. You can basically do a ton of different things with it. But the feature that we need with it is to decode or essentially extract frames from these videos. And one of the options are to extract keyframes. And keyframes, I guess also said as index frames, are essentially points in the video. So every time you click the skip button, it will go to a different point. Those are usually the index frames. So what I could do is I could extract just those frames, because otherwise if I did every frame, it might be thousands or tens of thousands of images. So it's better to come with like a certain subset of frames that you need, because you'll know exactly every time you extract those, it should be the same spot. And after we do that, we could actually then use AppleTools to validate that those frames, where they at, are identical. Because if they don't, if something does change, like somebody changes the format of the video or just modifies it in some way, then the keyframes will actually most likely be different. So here's some example code of there. You can see the download video where I'm just going to pass in a URL to get this VR video, or it could be any video on your hard drive, whatever it is, or network drive, or wherever it's at. And then I'm just running a command line of FMmpeg to extract those keyframes. And then finally, once they are extracted, I upload them all to AppleTools. So we'll see here, I sped it up. So it's going to download the MP4 file with the Blue Angels that we just watched. And here it's now FMmpeg after the video downloaded, it's extracting it. And once the extraction is complete, it will then upload to AppleTools for comparison. Yeah, so now I have an array of all my images, and now it's sending all those images to AppleTools. And here are my results. So now I have all my keyframes of my VR video within AppleTools for visual comparison. And each frame, these ones to the left is the baseline, right's the checkpoint, and it's the whole 360 video. So you can see the pilots in the middle, the co-pilots on the right, and I have my entire validation right there. So, helpful resources. The first one here, this is what I recommend if you guys don't already follow or know who he is Joe Colantonio. He's a big advocate for QA and automation. He has a blog post and podcasts, a lot of good content. As part of my research, I came across this air test framework, which looks pretty cool. Reminds me a lot of like what Sakuli was or is, where it's a record and playback based on images. So you highlight images and it will capture it, and you could record steps by doing that. And then a couple of different talks from BitBar, essentially kind of going over the stuff I did with using OpenCV and appium. This Rue Sindria, she had an awesome talk last year at the Appium conference about that same topic for basically using OpenCV appium for Unity apps. And then at the very bottom here, the code. So everything that you saw that I did up to this point, all the code examples are in this repository at the bottom. So now that you know how to test your VR app, you should be good to go. Any questions?
So here we go. Lots of questions. Very good. I think Erwin, you were first.
Hi, thanks for the talk. And my question is about smoke testing. You said that this OpenCV is quite slow. Have you thought about using a super primitive virtual setting, for example, like in Matrix, the white room or something like that, where you know the parsing is quite much more easier? You don't have to recognize objects. You put some specific objects.
Basically, you put in this specific region of where the object is. No, that's a good suggestion. I hadn't tried that, but good to know that it's.
Okay.
I will check it out.
Yeah, thanks.
Yeah, thank you.
I noticed that you were using quite a bit of, it was more like pixel-based detection, or I don't even know if you can, it's like pattern matching. Do you use any kind of feature detection or around that area? Or it's too computer vision specific?
For which part is the VR or
to identify the objects to anchor to?
When I was orienting the screen.
Exactly.
Yeah, so that was basically every time I was using an image to get the coordinates, and basically I would have to drag from the center to the object to get it to the correct position where I was going to do it. In that case, I was using OpenCV to do the comparison, just because of the slight pixel matching. At this point, at AppleTools at least, we are introducing a virtuality component as part of our testing. But in this case, OpenCV was a better choice to do the comparison. Hopefully that answered your question. Or
Yeah,
so,
it was okay. There was another question I saw early on here.
Hi, how do you evaluate the baseline images? Visually or?
Once you've created the baselines. So you set up your test script, whether it's going to be in OpenCV or in AppleTools. You always want to validate your baselines. So you run your script, your baselines are generated. You want to then make sure your baselines are absolutely correct because they are your baselines. Because your tests.
So visually.
Yeah, so you as a person still will have to look at it. Yeah, so it's not 100% automated. So you still have to basically say that it's still good or bad.
Okay,
Yeah, so,
thank you.
Yep.
Yeah, unfortunately in testing you still need to know what is the expected result.
Yep, we're not.
Any more questions? I want to see some hands.
To bribe them.
The pressure keeps on building. Maybe we have to use question assurance finally. So when do you think we can skip going to the conferences and just do everything in VR?
Yeah, that could be in the future, indeed. I wouldn't speculate on a time range, but we could have a reality conference someday. Yeah.
Super, and you can just do your speech from your bedroom.
Right.
So, thank you so much for coming.
Great,
it was
thank
a
you.
very interesting talk. And here's a little... So inside this bag there is a kind of a sleeping kit. It also includes a thing that looks very much like a VR. Don't look for the button to switch it on. It does not exist. It just put it on, it's black.
Yeah.
That means it works.
Okay, perfect.
Good.
All right, thank you.
All right, thanks.
Thanks, guys.